Good day to all. Today, I'm going to talk about correlation analysis. Say, for example, in your study, you have two different set of variables. How do you say that these two variables are related or not? So, to understand the relationship between these two variables, you can use correlation analysis. Say, for example, does one increases when the other increases? So, when your skill increases, does your income increases? Or say nutrition and health problems. So nutrition increases, does your health increases, or when nutrition decreases, does your health problems increases? So through correlation analysis, what we are trying to understand is to get the degree of relationship between these two variables, whether one variable causes another variable to go up, or the other variable comes down when the x variable goes up. So basic purpose of correlation analysis is to measure the direction and strength of the linear relationship between two quantitative variables represented by small letter r. So r is the coefficient of correlation, and through correlation analysis what you are trying to understand is whether it is a strong correlation, whether the two variables are strongly related, or whether the two variables are very weak in relationship. So, but you can quantitatively test these two variables and try to find out the strength of the relationship and also the direction of the relationship, whether when one variable, that is x, that is your independent variable, if one variable, that is your independent variable, goes up, correspondingly the dependent variable, that is the variable which is called as y, whether it goes up, then it is a positive correlation. That is one, because of one variable, the other variable also goes up. This is a positive relationship. When one variable increases, the other variable goes down. That shows that there is a negative correlation. That means it is negatively correlated. So what are the characteristics of this correlation analysis? So what the foremost characteristics, that is you can understand the direction of relationship between the two variables. So positive correlation means the two variables tend to move in the same direction positively. That is, when your skill level increases, your income also increases, right? So this is a positive correlation. Negative correlation, when nutrition level goes down, your health problems increases, right? So it is, one is going down and other one is going up. That is negative correlation. So this is how it is represented in the graph. That is the amount of the beer sold and the temperature. When the temperature increases, this amount of beer sold is increasing. That is, during a hot climate, you tend to consume more chilled beer. So that means when the temperature increases, the sales is going up. Here, when the temperature is going down, the amount of coffee sold is coming down. So it's a negative correlation. Second characteristics is it forms the form of the relationship, whether the relationship tend to have a linear form. In most cases, when you plot the data points in a graph, you get a scatter plot and it will show a trend that is in a linear relation. That is, when you combine all the data points inside the graph, you get a straight line. So that is the linear form. Or whether it is in a parabolic shape or not a straight line relationship, you can understand that using the correlation analysis. Second one is, third characteristic is the degree of the relationship. So a correlation measures how well the data fit in the specific form being considered. That is, if you get a score of say +1, that means it's a perfect correlation. That is, the two variables are highly correlated. If you get a 0 as the R value, then that shows that it is there is no correlation between the variable X and variable Y. And if you get a negative value, that shows that between X and Y there is a negative correlation. So it shows you the degree of relationship, whether it is a positively correlated or negatively correlated, or there is no correlation at all. Now, when and why should you use correlation? One is for prediction. If two variables are known to be related in some way, it is possible for us to understand and accurately predict the relationship between each other. So for prediction, you can actually use correlation. Second is validity. Suppose that you develop a new test for a specific purpose, and how do you show that this test is truly measuring what it claims? So by doing the correlation analysis between the two variables, that is x and y, you can show that in some way it is highly related. So for testing validity, you can use correlation. Then reliability. During reliability testing also, you use correlation analysis to understand whether it produces consistent measurement. If 10 times you do correlation analysis and you get 10 different values, that means that it is a highly unstable relationship. But then when you get a stable answer, then that shows that the test is reliable. Then for theory verification. And through when you do a literature survey and you understand that in some literature it is mentioned that two variables are related, and you want to test whether these two variables are related or not. To understand that relationship, you can actually use correlation analysis to test the relationship between the two variables. Now, types of correlation. Correlation can be divided into three types, that is type 1, type 2 and type 3. In type 1 relationship, it shows whether it is positively correlated or negatively correlated, or there is no correlation, or it is a perfect correlation. In type 2 correlation, it shows that whether it is linear relationship or a non-linear relationship. When you plot in the graph, and if you get if you are able to get a straight line through the data points, then that is a linear relationship. If you are not getting any kind of straight line, or if you are getting a curve, then that is not a non-linear relationship. So this is how it looks like. This is a perfect correlation, that is correlation is equal to 1. Here it is a perfect negative correlation, that means it is coming down and it is a -1 correlation. Here there is no correlation because all the data points are scattered in some way, and you cannot make any kind of relationship in this. So it is a no correlation, that is correlation is equal to 0. Here you can see that it is 0.8. It is coming into a linear relationship. So this is a linear relationship. Here it is very weak correlation because correlation is 0.2. So that means that the relationship between the two variables is very negligible. So what are the methods in studying the correlation? Correlation can be understood or studied in three ways. One is through a scatter diagram method, wherein you plot all your data points into a graph, scatter graph, and if you can make a linear line using the data points, then you can say that there is a relationship. And most commonly used method is Carl Pearson's coefficient of correlation method. And when it is a ordinal data, when the data that you have collected is ordinal in nature, then you can use Spearman's rank correlation method. Now, we have talked about what is coefficient of correlation, and it is represented by the letter R, and through this R value only you are trying to find out the relationship between the variables. So when you get the R value, you can understand whether it is perfectly correlated or there is no correlation or negatively correlated. So sign of R denotes the nature of the relationship, and the value of R denotes the strength of the relationship. So say, for example, if you are getting R is equal to -0.8, that means it is negatively correlated and it is a strong correlation. So you get the degree as well as the strength of the relationship. Say, for example, this is how it looks like. This is the continuum in which you can actually understand the strength and degree of the relationship. Say, so as I told you earlier, the R value, it lies between -1 and +1. That is the only value that you will get. If you are getting any value beyond -1 and +1, that means somewhere you have done wrong, and the correlation analysis that you have done is completely wrong. So R value you only get between -1 and +1. So say for example, if you are getting a R value of 0.75, that means it is a strong correlation. If you are getting say between 0 and 0.25, then it is a very weak correlation. So any value between 0.25 and 1 is comparatively okay. That means you are getting some amount of relationship, and this is the formula for calculating the correlation. And if you see the top part, that is xy minus sigma x into sigma y, that is the shared variability between the variables x and y, and the denominator is individual variability between x and y. So this is how that correlation is calculated, but we have a lot of software tools which helps you to do the correlation analysis, like SPSS, R programming, or even in Microsoft Excel you can actually calculate correlation. Only thing is you have to know what value that you have to look into, and you have to understand or interpret from the value. That is what matters the most. So this is an SPSS output. Here there are two things that you have to look into. First one that you have to look into is the significance value, that is a p value. You should see the p value. If your p value is less than 0.05, then that means the relationship between the two variables that you have selected for the study are significant. So that is the first thing that you have to look into this data. Second one is you have to find out the R value. Here the R value is 0.503. That means it is a moderate correlation. That is any value between say 0.7 and 0.5 is a kind of a moderate value. We'll see the interpretation. And there are certain assumptions also. In correlation, there is no distinction between the explanatory variable, that is the independent variable x, and dependent variable y. So there is nothing like if you put x value as y and y value as x, there is no difference. Okay, that is the first assumption. Then the null hypothesis tests that R is significantly different from the 0. That is another assumption that you make. And it requires both variables to be quantitative or continuous variable. Only then you can go for correlation. Both variables must be normally distributed. That is another biggest assumption that you have to make. That is the x and y should be normally correlated. If there is no if it is not normally distributed, then you have to go for Spearman's rank correlation method. Another assumption is no categorical or nominal variable. You can only test quantitative variables. Other variables like ordinal data or nominal data, you cannot do correlation. And R does not change when we change the unit of measurement. Say for example, you have changed it from say kilogram to milligram. It doesn't make any kind of difference, or it doesn't change the result. R value will be the same. And if there is outliers, obviously correlation will have an effect. So before doing the correlation analysis, you should test for outliers, whether you have data points which is beyond the maximum value. That is the outlier. So you have to test for that. So how do you interpret? If R is between 0.7 and -7, then it is a correlation. If it is more than 0.7 or between 0.7, then it is a strong correlation. If it is between 0.3 and 0.7, then it is a moderate correlation. And if it is below 0.3, then it is a very weak correlation. Now, Pearson's is the most commonly used correlation method. Whenever you use correlation, you usually use Carl Pearson's coefficient of correlation. And as I told you earlier, when you have a non-normal data or an ordinal or rank data, then you have to go for Spearman's rank correlation method, right? And what are the variables that affect R? R is affected by the range distinction. When there is no variability, when in standard deviation lecture, as I have mentioned that there should be variability in the data. When this range is less or the number of data points is too low, then it will affect the R. And if the data is not linear, if it is non-linear data, then again it will affect the R value. And if it is heterogeneous samples, that is the everyday samples that you take between height and weight, between men and women, these kind of data, it will also affect R. And if there are outliers, then also it will affect R. So these are some of the reasons or factors which affect the R value. With that, I am concluding my lecture for today. Thank you so much.